All right, so I want to do a little video on the first two modules of the Switching, Routing, Wireless Essentials course. This is actually probably my favorite course. It has a lot of interesting information. It actually gives you some configuration details. Like by the end of this course, you'll actually have information on how to set up DHCP on a router, set up wireless LAN, VLANs. It gives you all the configuration information, so you actually have something tangible that you can do by the time you're done with this course. Unfortunately, the first two modules are rather dry, if I must say, but I wanted to speed you through these, kind of give you like an overview of what to look for on the test and get you prepared for it. So let me share my screen here. Okay, so configuring a switch with initial settings. This is kind of like the sequel to Module 2 from the Introduction to Networks course. Some of this will feel like review. Some of it will be a little bit new as well. This is the boot sequence. There is a mix and match question on the test regarding this that you might see. First step is a post, and if you know anything about computers at all, a power on self-test is typically what the first thing that happens whenever you boot up any type of computer. Switches and routers are no different in that respect. If you can remember that that's the first step, and that the last step is that the bootloader loads the default iOS operating system, which is what we use to configure devices. That will help. Also, the bootloader, it comes in step 3. That's actually responsible. Excuse me. The bootloader actually comes in step 2. It is responsible for steps 3, 4, and 5. So the first step is the post. Second step is the bootloader is opened, which is stored in ROM. The bootloader does a low-level CPU initialization and does some other hardware testing. Then it initializes the flash file system, and then it loads the iOS operating system. This is in the book, so take a look at this and just be familiar with these steps. Okay, this is a test question right here. Oh, go back. I'm not going to write on the screen. The boot environment variable is set using the boot system global configuration mode command. That's a test question, so be familiar with that. You've probably seen this before. Any of our switches, Cisco switches, they have these little indicator lights on them. They kind of show what is happening within the switch, make sure that everything is working properly. And I'm actually going to show you this in action. This is what the each indicator means. Let me see if I can bring this online here. Okay, we got a switch right down here. I don't know if I'm going to be able to get it really in focus or not, but these are your indicator lights. That top light is basically the power indicator. It's showing that the switch is getting power and that it's functioning properly. Let me see if I can get a little closer on this. The one below that is RPS. That's redundant power supply. It shows the RPS status, which in this case, there's not a redundant power supply on this, so it's not illuminated. The third one down is STAT, short for status. And this, when you get down to these bottom 3, This is where you can hit the mode button down here and change your mode. By default, it lands on the status mode, and this basically allows us to see the status of each switch port. Basically, you want to see green. Solid green means it's up. Blinking green means it is up, and it is actively seeing data go through. So that was what we're seeing here. Now, if I hit the mode button once, that changes it to the duplex mode. And now, the indicator lights on the switch ports, on switch port 1 and 15 there, they are showing solid green, which means they are both in full duplex mode. For a half duplex, those lights would be off. Hit the mode button again. Goes down to the bottom one, and notice we had a little change there. And that is the speed setting. And the speed setting, solid green is a 100 megabit connection, fast Ethernet, and blinking is 1000 megabits. So port 15 is a gigabit connection, and port 1 is showing a 100 megabit connection, probably because the other end of that is a 100 megabit port. The fourth one is not on this. This device doesn't have PoE, which is power over Ethernet, but that would PoE would is on some of the switches. Let's go back to share my screen again. Okay, go. So be familiar with what those light indicators mean. There might be a test question or two, but that's really just good information to know in general. All right, recovering from a system crash or recovering from losing a password to log in to like privileged exec mode, for instance. These are the steps to that you would go through. Basically, you need to connect like a laptop or a desktop, via a console cable to the switch. Power off the switch by unplugging it. Plug it back in. Hold down the mode button until it, turns amber and then solid green. Let go, and then the bootloader switch prompt will appear, and then you can have command line access to recover your switch. So be familiar with these steps. You might see a test question on that as well. Switch management access. As if you recall from Module 2, switches do not need IP addresses in order to function properly, but if you want to manage them remotely, you do need to assign a switch an IP address so that you can remotely access it. Also in Module 2 of the Introduction to Networks course, you did learn how to set up a switch virtual interface. It's also known as a management VLAN. You'll learn more about VLANs in Module 3 of this course, but best practice for a management VLAN is not to use VLAN 1, which is what you did use in Introduction to Networks. Best practice is to change that to another VLAN. In this instance, or in this example, they're showing VLAN 99 as your management VLAN. These are the configuration commands, and they should look somewhat familiar to you all if you've gone through the ITN course. Interface VLAN 99. It was VLAN 1 when you did the packet tracer in Module 2. Set up the IP address. You can set up an IPv6 address, enable it, and then save your configuration. This should be a review for the most part. If you are accessing your switch from another network, in other words, you have to go through a router logically to get, to access your switch, you need to specify the IP default gateway on that switch as well. Otherwise, you won't be able to access it. And these are the commands to do so. And of course, anytime you do a configuration, it's always good to verify your configuration and test it after the fact. Show IP interface brief is a good way to quickly look at the status of your switch, of your physical and virtual interfaces. Okay, so configuring switch ports. Most switches are set up to auto-negotiate the duplex mode by default. In other words, half duplex or full duplex. But you can specify full duplex or half duplex depending on the what equipment you have on your network. You may have a legacy device that requires half duplex, and then in which case you can specify that. If you have half duplex ports, then you have a collision domain, which means that basically two interfaces that are connected to each other are competing for the same network resources. Full duplex, there is no collision domain. They can each send at the same time. And switches also auto-negotiate speed by default, and that can be manually configured as well. These are your commands to set those up. In this instance, we're specifying full duplex and a speed of fast Ethernet or 100 megabits. If it was a gigabit, it would be speed 1000. If it was half duplex, it would be duplex half. Auto MDIX. If you recall back in probably module 4 of ITN, whenever you are connecting two like devices, in other words, two routers connected together or two switches connected together, it's best practice to use a crossover cable. It's not absolutely necessary because switches that have been made in the last 10 or 20 years all have something called auto MDIX enabled, which basically allows a switch to automatically configure their port based on what type of cable type is plugged in. In other words, it can sense the cable type and will adjust accordingly. But sometimes you will come across older legacy equipment on a network, so it's good to know in those instances, and also for your certification exam, that the proper type of cable to use to connect two like devices is a crossover cable and not a straight through cable, even though both will work on newer equipment. These are good commands to know for troubleshooting. Some of these you've seen before. Show startup config, show running config. Show history, that's one that you probably haven't seen before in ITN. By default, the last 10 commands are saved in memory. And if you use the show history command, you can see the last 10 commands that have been used on a switch or a router. Show running configuration is one of the simplest things you can do when troubleshooting, is just to look at the current configuration. You've all probably have used that by now, I'm sure. Show interfaces displays status and statistical information on the switch ports. As you can see on the next screen here, we get the full display. A lot of information on here, including errors and things like that. Notice that in this, it's specifying this is a full duplex connection. That's a lot of collisions for a full duplex connection. Excuse me, COVID. This is a list of some errors you may encounter. Runt frames, those are Ethernet frames that are shorter than the 64-byte minimum allowed. There's a test question that might be about that. Malfunctioning NICs are the most usual cause of this, but they can be caused by collisions as well. Giants, those are Ethernet frames that are larger than the maximum allowed size. CRC errors, those are usually caused by bad cable or bad media, either a bad cable or a bad Wi-Fi card perhaps. This can be caused by interference as well. You see a lot of CRC errors, you probably should check for sources of noise, like electromagnetic interference type noise, and also inspect cabling. Collisions in half-duplex operations are normal. In theory, you should not see collisions on an interface configured for full duplex communications. And late collisions, I think there's a test question about this. Late collisions are most commonly caused by two things: excessive cable length, and duplex misconfiguration, where one end of an interface is manually configured for full duplex and the other end is configured for half duplex. Those are your two most common culprits for late collisions. Securing remote connections, remote access. Telnet is a fine choice to initially set up a network, or if you're on a network that is isolated from outside networks. However, once you have a network that is in production mode, in other words, it's in a production environment, is live, it should be limited to only secure encrypted connections through SSH. SSH looks a lot like Telnet, but it is, because it's encrypted, it's secure. These are your steps for setting up SSH. There is a packet tracer lab in module in module 1 to practice that. If you're ever setting up a network from scratch, or if you're installing a new network, new equipment on a network, knowing how to secure it properly with SSH is an important skill to have. So you might want to go through these steps. It's in the book, and of course, practice on the packet tracer. It's useful. Show IPSSH is a command to get some basic information in the version. And of course, you want to test it. Once you go live with it, test the SSH connection, and also test the Telnet connection to make sure that it's not functioning. That it's not able to access it, use the device using Telnet. That's a show IPSSH command to get version information, basic information. All right, and here's the sequel to Module 10 from the Introduction to Networks course, Basic Router Configuration. This should seem somewhat familiar to you. A lot of it is review. Routers and switches have very similar initial configuration steps. Set up a banner, very much the same way a switch is set up in this instance. The two biggest differences between setting up a router and a switch. Router, you must specify an IP address on the interface in order to enable it, and you must actually manually enable it because it is in a shutdown state to begin with. Switch ports are by default in an up state by default, and you don't assign a IP address to their interfaces. Just configuration commands for router interfaces, again, should look very familiar. You've all done this by now if you've gone through the ITN course. Okay, a loopback interface. This is something that is maybe mentioned in ITN somewhere, but is not talked about in detail. Loopback interfaces are logical software interfaces. They're primarily used for testing purposes. You can basically emulate a network um, without actually setting up a physical network using loopback interfaces on a router. Commands to set up a loopback interface, very easy. Interface, loopback, specify a number, give it an IP address. Loopbacks are enabled by default. And some useful commands, again, show IP interface brief. You should be familiar with that one. It gives us the status of all interfaces on a router and a switch. Show running config interface command. It'll display the current commands applied to the specified interface. So if you want to look at what the configuration is on gigabit 00, instead of doing a show running config, you could type show running config interface gigabit 0/0, and it'll show you the configuration for that interface rather than pulling up the entire running configuration file and scrolling through. It's useful. We will get into routing more in this course. We touched on it in ITN a little bit, but we'll go into more depth during the Switching Routing Wireless Essentials course. Show IP route. We'll show the routing table on the router. You'll learn about these codes later, but I'll tell you the two that are listed here. C stands for directly connected network. That's any network that is directly connected to the router. And L stands for local host route, and that is literally the IP address that is on the interface. Frame forwarding. Okay, this is part of Module 2, so I'll go over some things you need to watch for on the test. Switches use their MAC address table to make forwarding decisions. This should be somewhat review for you. What is maybe not review is that the MAC address table is also known as the CAM table. I don't see that listed on here, but that does show up on the test. CAM, C-A-M, stands for Content Addressable Memory. So if you see a test question referring to the CAM table, know that the question is referring to the MAC address table. The switches learn by examining the incoming frame source MAC address and the incoming port. Basically, it's a two-step process, for what a switch, decides to do with a frame. It examines the source address. If the source MAC address is not in the MAC address table, it'll add that to the table with the incoming port. If it is in the MAC address table, it'll reset the timeout setting back to 5 minutes. The next step is it forwards it on. If the MAC address, the destination MAC address is in the MAC address table, it will forward it directly to that port. If it is not, it will send it out all ports, except for the one that it came in on. Okay, here's a test question for you. ASICs reduce the amount of handling time inside the switch. ASICs are application-specific integrated circuits, ASICs. They reduce the amount of handling time inside the switch. There's two methods used to forward frames, store and forward and cut through. Store and forward is the preferred method. Store and forward offers error checking and buffering. There's a test question on that. This method ensures the frame is error-free before sending. That's its big advantage. It will ensure that the frame is error-free before sending it on. Cut-through switching, its big advantage is speed. Its disadvantage is it will pass along errors if there are errors in the frame. There is a compromise approach within cut-through switching. Another type of cut-through switching is called fragment-free. Fragment-free method, it basically looks at the first 64 bytes, and if no errors are detected in that, it will pass it along. It's a good compromise because most errors actually occur in the first 64 bytes. All right, switching domains. We talked about collision domains a little bit. A collision domain occurs whenever there is a half duplex link. So if there's a half duplex link on a switch port, that is a collision domain. And basically what we're talking about is two interfaces that are competing for the same network resources. Now, in half duplex, you can only send one at a time. You can't, both interfaces can't send at the same time. So they're kind of fighting with each other for that network resource. Broadcast domains. There's a couple test questions about this, so pay attention to this. Broadcast domains occur across all layer 1 and 2 connected devices. Routers separate broadcast domains. And here, this is a broadcast domain. This is a switch with 5 devices. If you add a second switch onto this, you are increasing the size of your broadcast domain. Let me kind of illustrate how this is. Let's call this machine right here PCA. If PCA sends a broadcast frame to switch 1 will send it out all ports, right? To these 4 devices. If we add a switch, down below we've added a second switch. Now if PCA here sends a broadcast frame to switch 1 will send it out all ports, including this port to switch 2. Switch 2 receives this broadcast frame, and it's going to do the same thing. It's going to send it out all interfaces. So by adding a second switch, we have doubled, or have increased the size of this broadcast domain. If we were to put a router in between these two, we would separate these two, and these would be 2 broadcast domains. If there were a router, imagine a router right here. All right, here's some switch features to become familiar with. I think there's at least a couple of test questions buried in this. Fast port speeds. Switches with faster port speeds can reduce congestion. And if you think about it logically, that kind of makes sense. I mean, the faster the port speed is, the faster it gets rid of information, the less likely you are to have information kind of hanging around on the network. It's, the faster the port speed, the faster it gets rid of it. Fast internal switching. Switches use a fast internal bus or shared memory to provide high performance. Large frame buffers. So switches use large memory buffers, basically, to temporarily store more received frames when there's a lot of network congestion. If there's a lot of network congestion, a switch will use that memory to kind of store those frames so they don't get dropped. And high port density. Switches with high port density help keep traffic local, which helps alleviate network congestion due to collisions. And that is the end of modules 1 and 2. I do recommend that you take the module 1-2 quiz, which is located on the main course page under the modules 1 through 4 heading. That'll help you kind of practice for the test. And again, if you have any questions, you can leave a comment or contact me via email. Oh, and my 8-year-old subscribed to my YouTube channel. I got to tell you this real quick. he was critical of me. He had some criticism about how I am doing my YouTube channel. My 8-year-old is critical of me. He told me that I need to remind everyone to subscribe. So please subscribe to my YouTube channel. Oh, and I should have a goal of how many likes that each video should get. I have like 8 subscribers, so I'm going to ask that half of you, 4. I'm looking for 4 likes on this video. Thank you and have a great day.